In this section, we are going to be graphing these quadratic functions. So remember that a function is always written as f of x. So our y value is now changed to a f of x thing. So what we're really going to be looking at is what exactly does f of x equal x squared look like? So we already know that a quadratic function, f of x equals ax squared plus bx plus c. We're first going to look at what f of x equals x squared looks like. So we're first going to draw a little x and y axis. Let's write a little table up here. So, because remember, y is just f of x. So what happens when I plug in 0? Okay, so when I plug in 0, I'm going to get 0 squared. I still get a 0 back. So I'm going to plot that 0 there. What happens when I plug in 1? Well, when I plug in 1, I'm going to get 1 squared, and you're going to get a 1. So when I plug in 1, I'm going to get a 1. What happens when I plug in a 2? Well, when I plug in a 2, I'm going to plug it in here. 2 squared, that gives me 4. So 2, 1, 2, 3, 4. Okay, and so on and so forth. So this one looks like it's kind of looking like this. Now I need to put some negative values. So what happens when I put a negative 1? Well, negative 1 squared is also going to give me a positive 1, and negative 2 squared is also going to give me a positive 4. So when I plug in negative 1, I'm also going to get a 1. When I plug in negative 2, I'm also going to get a positive 4. So if you can see, this actually is symmetrical to the other side. Okay, and what we call this shape, we call it a parabola. So anything that has an x squared is going to be called a parabola. Now a parabola has different things. So here, if I were to draw a little line, it looks like a little mirror. This is what we're going to call the axis of symmetry, because this is where it actually is symmetrical. This thing, this lower part, is what we're going to call the vertex. Okay. Now, if we were to look at different values, so let me just take this part. Let me just write the most general quadratic. So f of x squared, f of x equals x squared looks like this. Okay, it looks like a parabola, very like a U shape, a happy face. Now, if I were to take this thing, ax squared plus bx plus c, and I were to graph many different things, well, you're going to have two different types of problems. Okay. So sometimes you will encounter a happy parabola, something that is going upward. Or you might encounter something that is kind of like a sad parabola going downward. Now, how do I know if it goes upward or downward? Well, it all depends on the value of a. So depending on whatever this a is, if a is a positive number, this means it's positive, then you're going to have something that's happy. If a is a negative number, then you're going to get something that's sad. Okay? Here we have our vertex. This vertex is what we're going to call our minimum, because it is at the lowest point and everything else is upward. Here, when you have a sad parabola, your vertex is going to be a maximum because it's at the highest point. Okay? All right, now let's look at a couple things. One of the things that we really want to take a look at is how do we find this top point and this bottom point? Okay, because we do want to graph them, but like let's say we had a really complicated graph. We don't just want to plug in numbers, kind of like how we did here. This was easy, but maybe if we want to solve more complicated problems, then it might be difficult to just keep plugging points. So the first thing that we're going to look at is looking at the vertex. So how can I find the vertex? Finding vertex of a quadratic. Okay, so there is a formula to find the vertex. The vertex is the following thing, and the vertex actually is an x and y coordinate. So see, this is x and y, this is x and y. Well, the x value, in order to find the x value of the parabola, what you're going to do is take this negative b divided by 2a. In order to find the y coordinate, you're just going to basically plug in this negative b over 2a back into the function. So this is the formula that you will have to use. Where this formula came from, well, there is a derivation, and if you really like to look at it, I can do a video if you want to, but it's not really important. And you'll eventually see some sort of derivation in a much more complicated math class. So this is how to find the vertex. These are the two things that you need. You need to find the x value, and you need to find the y value. Okay? So let's give you an example. Okay? So we have f of x is equal to 3x squared minus 6x plus 2. And what we want to do is find the vertex. Okay, so in order to find the vertex, we have these formulas. So let's first figure out what x is. X is going to be negative b over 2a. So here, negative is going to be right there. Our b is negative 6 divided by 2 times a, which gives me 3. A negative and a negative give me a positive 6 divided by 2 times 3, which gives me 6, gives me 1. Okay, so that is my x coordinate. My y coordinate now is going to be me plugging this 1 back into the function. So f of negative b over 2a, well, that's just negative b over 2a was equal to 1. So I'm going to plug in 1 into the function. So it's going to be 3 times 1 squared minus 6 times 1 plus 2. This is going to give me 3 minus 6 plus 2. So 3 minus 6 is going to give me negative 3 plus 2, which gives me negative 1. Okay, so my vertex is going to be equal to 1 comma negative 1. Okay, so that's where it reaches its lowest point, because if you look here, a is positive. So when I graph it, right, it's going to look something like that. And you're going to, here is going to be 1 comma negative 1. Okay, that's my lowest point. So it's going to be a happy parabola. It's going to look something like this. Okay, so that is one step that we can do to find the vertex. Okay, so to find the vertex, very, very simple. Let's just do one more problem just to make sure that we really get it. Find the vertex. Okay, let's say we had f of x is equal to 2x squared plus 8x plus 1. Okay, and let's make this negative. So here, let's just take x equals negative b over 2a. Negative b in this case is equal to 8 divided by 2a, in this case is negative 2. I have negative 8 divided by negative 4, which is going to give me a positive 2. So that's my x coordinate. My y coordinate is plugging in positive 2 into the function. It's going to give me negative 2 squared plus 8 times 2 plus 1. So 2 squared is going to give me 4, so negative 2 times 4 plus 16 plus 1, negative 8 plus 16 plus 1. This is going to give me 8 plus 1, which gives me 9. Okay, so my vertex is going to be equal to 2 comma 9. Okay, so that means that when I graph it, so here's 2 comma 9, this is going to be a sad parabola because it's negative, so it's going to be going downward. Okay, so it looks something like that. Okay, now we don't want to have this because we want to know, okay, well, how skinny or how fat is this parabola going to be? Like, is it going to go here? Is it going to go out here? You know, where exactly is this parabola going to be? Well, another way that you can do it, so right after you find the vertex, something else that you can do to further try to graph it is to find the x and the y intercepts. Intercepts. Okay, so let me just tell you first what an x-intercept is. An x-intercept is basically where the graph crosses the x-axis. Okay, all right, and usually how you find it is you set y equal to 0. Okay, the y-intercept is where the graph crosses the y-axis. And in this case, how you find it is by setting x equal to 0. Okay, so let's go back to the previous problem that we had. Let's do this example. Okay, f of x is equal to 3x squared minus 6x plus 2. And what I want to do is find x and y intercepts. Okay. So, try this problem, and this actually let me finish this let me finish this up. Let's let me put this in the next video. That way, I have more room because I ran out of room. And then we'll continue.